Hello everyone, my name is Dave Kachuk of Symbol Logic, creators of Engineering Complete AV, and welcome to early stage and next stage documentation. I'm really excited to present this class to you today, particularly because of how much easier it is to achieve the necessary documentation we need for our projects. CEDIA is promoting proper documentation in its books and online training. There's now more choices in do-it-yourself drawing software, as well as outside drafting services that you can use. ESD, early stage documentation, and NSD, next stage documentation, were separate classes, but today we've combined both into one presentation, so you can get an uninterrupted look at the benefits and the details of the design, engineering, and wiring documentation process for your own projects, from sales to project completion. Today I'm going to show you examples of early stage and next stage documentation that'll help you sell more projects, provide a better roadmap for your technicians and programmers, and allow you to make your projects safer and more reliable. You can choose to outsource your drawing work or to do it yourself in-house. We'll discuss this in more detail at the end of the presentation, but in either case, pay very close attention to the drawing examples you see today, as they represent decades of sales, design, and installation experience you should be using in your own businesses. The examples shown today were created using Symbol Logic's ECAV, a do-it-yourself visual application suite. Just a quick look at our agenda. In the introduction, we'll go over the key documents of ESD and NSD. Then we'll take a deeper dive into ESD and why it's so important for helping sales and jump-starting the whole documentation process. We'll take a close look at some of the details NSD provides and how that's important not only to finish a project, but to finish it effectively and efficiently. After that, we'll quickly look at something called room AV layouts, the printed output, and as-built drawings. And we'll finish up with ways you can incorporate the ESD and NSD process into your own businesses. So let's get started. Not a pretty sight. Sad but true. But we've taken a hard and close look over many years at the way the AV industry had been doing AV drawings and building their systems. And what we found was that most of the fragile and dysfunctional systems had very little, if any, documentation to properly build and support the systems. And according to HTA, only 5% of successful dealers utilize documentation properly. And it wasn't necessarily the integrator's fault. The existing methods and tools at the time were also lacking. We know this because as a long-time installation company and working with many integrators, we all struggle to document and build our projects with an appropriate set of plans. Existing methods of documentation were inefficient, imprecise, missing important data, and on top of that, whatever documentation was available was very hard to read and understand. There had to be a better way. So we set out to develop a whole new approach to creating and using design and engineering documents. You might say a blend of science and art to help us work smarter, improve efficiency, accuracy, and detail, and with the drawings being easier to read and understand. So we could turn this into this. And this. Now this doesn't just happen. These systems are real examples of using effective documentation. Why do we show the backs of the racks? Because the fronts usually always look great, and you can't tell much about a system without looking under the hood, right? You can tell a lot about the whole installation by looking at the not so obvious areas. Yes, these racks really look nice, but an organized rack is easier to service and upgrade, has better ventilation for longer equipment life, and with racks that look like these, there's a very good chance a lot of good design and engineering went on behind the scenes. And we've seen clients' reaction to the backs of these racks. They had no idea that kind of professionalism was going on. They now get a better understanding of the value of their system and what integrators do on the back end to make it all happen. So today we'll look at this carefully carved documentation approach using examples and some of the important details necessary to get us over this finish line efficiently and successfully. So, in order to get there, let's first go over what ESD and NSD are. First, ESD, early stage documentation, are drawings and documents that visually define a project's physical layout and design. ESD includes the AV floor plan and system block diagram drawings. These drawings show the location of the generic devices on the property and defines the pre-wire schedules. Early stage documents are relatively easy to create since exact product models aren't necessarily decided yet, and generic shapes and symbols can be used to create the design. ESD is used to help sell the job, define the proposal, and helps launch NSD when the project is accepted. Now that you've won the project, next stage documentation, NSD, kicks in and becomes a continuation of ESD. NSD are drawings and documents which show specific products, product IOs, wiring, and rack mounting details of the project design established in ESD. NSD includes the system block diagram, but now with product models, the head-end and room schematics, and equipment rack drawings. Each of the early and next stage documents solves an important sequential design or engineering challenge. ESD, device locations. The AV floor plan drawing defines where key items like speakers, TVs, access points, etc. will go in and around the property. Design. After we know where key devices are going, how do we show the full size and scope of the project? That's the system block diagram, which is a one-page layout of the whole project showing all the rooms, devices, and pre-wire connectivity. Pre-wire. After we've established the design, how do we convey the system pre-wire, and where will the pre-wire schedules be generated from? That's also from the block diagram. Notice the overlap between ESD and NSD. They each have a block diagram section. In ESD, you may not yet know specific products in your design, but you will need to know the products in NSD before moving forward. So ESD could be a new or on-the-fly, got to get this done quick design without specific product models yet. Or ESD could be a design you're familiar with and you do know the product models. In either case, you're usually good to go with pre-wire because, for the most part, pre-wires don't require you to pick specific product models. NSD, products. What are the actual products we'll use to make the overall design work as intended? Again, use the system block diagram. This is where we now insert product models. An important question to ask yourself: do we design only around our limited set of products, or do we use products based on the required design? A good design practice should not involve product selection until the full system size, scope, and functionality is established. If you find the need to use something outside your comfort zone of limited products, then always verify that any new products are fully vetted before you use them. Jumping to connections. Only after all the product models are chosen that fulfill the design, how can we clearly and accurately convey to our text the point-to-point wiring needed to make it all work as expected? That's the head end and room wiring schematics. Power and ventilation. How can we install our systems without first knowing the power and ventilation needed? If we don't figure this out correctly, we can either over-engineer our systems and waste a lot of money in product, or we could under-engineer it and likely shorten the equipment lifespan. The AC current and ventilation requirements can be calculated right from the schematic drawings. And lastly, how do we show all the necessary details for the techs to build the racks? Having done all the necessary design, product selection, and engineering work, we can now, of course, create the equipment rack drawings. So, together, ESD and NSD complete the full documentation package needed to help sell, build, program, and service your projects. Now let's look at the actual drawings. Device locations. Again, the best way to show device locations on a project is by using the AV floor plan drawing. It's not only used internally for the installers and other project stakeholders, but as mentioned, for sales as well. The AV floor plan drawing is relatively easy to create and requires very little work just by dragging and dropping device symbols onto the client's floor plan image. Then you'll have a professional looking drawing that can have a very positive effect on your potential client. Let's take a closer look. So, how is the AV floor plan used in sales? You can demonstrate your solution to your potential client by showing them the AV floor plan along with your proposal. They'll visually understand the scope of work and that you're not just selling products, but designing and engineering lifestyle systems. Your professionalism will help speed up their decision process, and you'll likely close more sales. And after closing the deal, this drawing is shared with the client to confirm what is being installed and where it's being installed. Getting this drawing confirmed before any installation work is done is the foundation for a successful installation. This drawing also lays the groundwork for creating all the other drawings. We use legends to describe what the symbols on the page are in real life. All the symbols follow a certain color scheme, which is carried through on the later block and schematic drawings. These color categories represent the different systems that you sell and install. Symbols can also show status, such as new or existing, which are client-furnished devices, or future devices where only wiring is to be installed. Where and how the devices are mounted, such as wall or ceiling mounting. They can even show the exact recommended heights above the finished floor. One important note: The pre-wire can be shown on this AV floor plan, but there's a good chance you'll miss one or more wires. And this is because not all project devices are shown on the floor plan. Remember, the AV floor plan is really a conceptual drawing showing only key devices that the client needs to see, not a full design. And that's one of the reasons why we need a full system block diagram as well. In addition to showing key devices and locations, we can also show distances and direction angles to other points on the drawing, as well as coverage areas and angles for access points, security cameras, projector lenses, and motion sensors. You can see the security camera on the left with its green coverage angle of 45 degrees. And the access point or gateway in the middle of the page showing its specified coverage pattern in orange. We can also show keypad engravings. On the lower right side of the page, we see a lighting keypad with engraving pointing to the lighting keypad symbol location. This can be very useful where the client or lighting designer walks through the plan, checking the engravings and signing off before ordering is done. Additionally, any unique or custom symbol and icon you might need to stand out from the standard symbol library should be simple to create. Design, the system block diagram. Here we had to develop a unique diagram which bridged a previously huge gap between the AV floor plan and the wiring schematic drawings. Integrators were jumping right into creating the wiring schematics without first seeing the overall big picture of the whole system. So, the full system block diagram was developed to be sort of a template where you can lay out any project or brainstorm any conceptually new design. The layout generates the pre-wire schedules and bill of materials and becomes the foundation for all next stage engineering documentation, including schematics and rack drawings. And it was developed with helpful drawing guides for easy symbol alignment and layout. Now, the AV floor plan is essential in designing a system, but it can only show so much information. So after the AV floor plan is approved, the block diagram is created to show the overall full system design. The block diagram shows in a riser-style fashion all the devices, all the rooms, all the floors, and all the connections between the racks and the rooms, all on one page. All rooms on the right, head ends on the left, and floor identification bars on each side of the diagram. Broken lines define each room and head end area, and the floor bars identify which floors the head ends and rooms are on. The development of this drawing was a major undertaking to make it easy to create in a clean and easy to understand way, regardless of the size or complexity of the system. And like the floor plan symbols, each block device symbol is color-coded for easy category identification. The block diagram page also shows the device legend, pre-wire lists, and bill of materials. Looking a little closer, each and every room is shown, including all devices, basic connectivity, and all pre-wires needing to be run, sometimes, as we all know, tomorrow. That's why this drawing was designed to be easily delivered almost immediately after the floor plan is done. Devices can be generic if they haven't been determined yet, or they can be specific models. In this example, the design is finished with model numbers selected to perform to the agreed upon design. The reference ID is the link between the drawing and the company's database, which we'll see shortly. As mentioned earlier, regardless of the chosen equipment models, the pre-wire design can usually be established almost immediately. Each wire type, wire color, is chosen for its particular function, and a unique wire number is set for each wire. The head ends shown on the left show the devices in each of the racks with basic connectivity. The apparent colored wires in the head ends are not wires at all, but wire groups representing bundles of wires coming in from the rooms. Each wire group in the head end shows the total number of room wires with the same group letter. And this is great for techs to make sure they have the same number of wires pulled as shown on the block diagram. Each of the block diagram rooms and head end areas can be individually printed out and placed at each room's entry on the job site. And this helps the techs to clearly and quickly see what devices and cables each room is expected to have before sheetrock. As mentioned earlier, without yet knowing exactly what to be selected for head end and room equipment models, the pre-wire schedules can still be determined. The pre-wire schedules are generated from the system block diagram and can be shown with wires sorted by wire type, location, or wire ID for printing out wire labels. In each schedule, each row represents a unique wire run in the system. Schedule headings include a minimum of from area to room name, wire type, and wire ID or wire number. This wire schedule by room is mainly intended for installers to know which wires are being pulled to, usually the room, and pulled from, usually the AV rack or head end. Since these schedules are created from the block diagram, all wire lists will be accurate and complete. Products, which are part of the block diagram. This is a typical integrator's spreadsheet of product data or their company database. It should only include products you've had success with in previous installations. Or if it's a brand new product without an installation track record, obviously you should have tested it in your shop first to know that it actually works the way you expect it to work. The catalog includes the physical and electrical data needed to correctly engineer the system. The spreadsheet and block diagram are easily linked together. The block diagram is then used to generate the bill of materials, power and ventilation requirements, schematic and rack elevation drawings. You can easily build your own spreadsheet, or other companies may provide that service. With the completion of the block diagram, the detailed point-to-point wiring connections or wiring schematics can now be created. And although the schematics are the most detailed of all the drawings, creating and configuring the individual schematic symbols should be very easy, and other companies may provide that service as well. Shown on the left, the printed schematic page is often used as a wire schedule for racks and room electronics. Each line on the diagram is highlighted only after each cable is routed, terminated, and labeled, allowing any installer to come in the next day and pick up where they left off. and different text can use different colored highlighters. In the right image, you can see the head-end schematic page taped to the wall to help in tying in a newly delivered head-end rack to the existing house wires. So, these engineering drawings are the point-to-point wiring schematics for the AV racks, theater racks, and any head ends in room electronics. They're detailed drawings that show much more than can be shown on the previous block diagram. They're created with the help of the block diagram and follow the same category color scheme for the device symbols. And notice we have both the audio rack and video rack on the same C-size drawing page, that's 24-inch by 18-inch. A left to right signal flow helps prevent confusing wire crossovers and makes the diagram easy to follow. Broken lines define the racks. Power management devices are on the bottom left of the page and out of the way of AV control and network equipment. It's uncluttered, yet it's got all the technical information the techs need without having to go elsewhere to find the details. All the same features apply to room schematics as well, except in room schematics we show TVs, projectors, lifts, speakers, touch panels, remotes, thermostats, and all associated support equipment. And as I mentioned earlier, individual printed pages of each room in the block diagram is stapled at each room's entry on site to provide the techs a check for all pre-wires and room designs before sheetrocking. The same again here with room schematic pages for the finish. Here, the techs use each room's drawing page to install the room's equipment. Let's take a closer look at these schematic details. On the right side of the amplifier symbol, you can see pre-wire cable connections. All pre-wire cable colors and wire information is shown, as well as each cable's destination. All pre-wires and interconnect wires are appropriately numbered with cable type and color. Schematic device input and outputs show a lot of important information as well. Each device I/O shows the device's label, that's the product silkscreen text, the quantity and type of connectors needed for each termination, and the termination detail number. And this number is matched to the detail on the far right for techs to know how to make their connections. No guessing and no need to look it up. In this slide, you can see how reference pairs, which are small diamonds, circles, and squares, rather than drawing lines, are used to represent certain wires and functions. These are used to clean up the drawing without any loss of wiring detail and make the drawing easier to read and understand rather than having a web of drawing lines going everywhere. Notice the use of special callouts to help the text with important notes. Some devices are shown with shadows, and this indicates that these devices are not front-mounted in the rack, and this helps the techs better plan the layout of the racks. The schematic should also be able to clearly show and distinguish between a mainframe chassis and their I/O cards with models and slot numbers. Notice on certain device symbols there's a current draw and power group connection number such as group G1. The sum of these AC currents determines the overall system current for the group, which should not exceed the maximum allowable current capacity of the connected PDUs or UPSs. Shown here. So, working behind the scenes are calculations for the total system current draw, wattage used, and ventilation requirements. Let's take a closer look. Remember what I said up front about the importance of knowing the power consumption and ventilation requirements for our systems. If our equipment draws too much current or power, say when the music gets loud, we could trip a service panel breaker or the breaker in our own power distribution devices, that is the PDUs or UPSs. So by analyzing the current and power usage of the devices in our drawings, we engineer the systems to not exceed the maximum allowable current and power for our service panels and power management devices. Let's take a closer look. But it's sometimes a bit of a challenge trying to find the current, power, and BTUs for our products and include it in our company catalog. Many manufacturers are very stingy with this data, and it's sometimes very time-consuming to find it. It's not always on the spec sheets, and sometimes you have to look at the back of an actual unit to find the current or wattage. And finding the heat or BTUs of a product is even harder if it's available at all. So what we did is develop a special power and heat calculator for each symbol that computes all the data we need even when only one piece of data is available. So with only one data item, all other calculations are made with very good approximations. You can see in this generated report that the total power consumption for connection group 1 is 1,361 watts, which is well within the UPS capacity of 1,650 watts. This is good, and this is safe. The same holds true for power connection group 2 in the audio rack. 601 watts consumed versus 750 watts available. When it comes to AC power, there are two concerns for PDU and UPS overload. One is watts, which we just confirmed in the previous slide to be safe. The other is current, which also cannot be exceeded in our systems. In this slide, you can see our system is safely engineered for current as well. The total video rack current draw is 13 amps, while the current capacity is nearly 18 amps. Safe margins for the audio rack as well. About 5 amps total current draw versus 8.8 amps of current capacity. What about the total current requirement for both our racks? Here we see 3 power connection group subtotals. Why 3? We only have 2 racks, so what gives? Well, the third power group has to do with the 2 audio power amplifiers, which typically draw more than PDUs and UPSs can handle. So they are both directly connected to a third surge protection circuit. So we see here the total needed current for the rack is 30 amps. So 3 separate 20 amp circuits will be used here. Providing some AC headroom is always a good thing. Now let's look at our needed ventilation. We can see the calculations for the audio and video racks total about 368 cubic feet per minute. This calculation is based on an outside rack temperature of about 75 degrees Fahrenheit to maintain an internal rack temperature of no more than 85 degrees Fahrenheit. This not to exceed 85 degrees standard is generally recommended for providing normal equipment life. So, with a 368 CFM requirement, this is one of the choices of ceiling exhaust fans that we can use to serve the purpose. Again, provided there's enough 75-degree air outside the racks. It can be mounted in the rack room ceiling to exhaust the heated rack air into a return duct or other separate space. And a thermostat can be installed within the rack to start the fan when 85 degrees Fahrenheit is reached. Equipment layout. In this next section, we'll talk about the equipment rack drawings needed to build our racks. Here we see the project's video rack layout. Notice the rack to the left on the page is not a separate rack, but a back view of the rack showing anything that the techs may need to see. Equipment placement. The rack ruler is used to help the techs match the mounting of the equipment in the rack to the drawing. Also notice the useful horizontal or vertical mounting of devices and whether devices are new or owner furnished. Notice the heavy gear like UPSs and AVRs are located at the bottom. This, of course, lowers the center of gravity for the rack, so it's relatively stable and safe while working on it. Notice the depth bars on each piece of equipment. They show the depth of each piece of equipment compared to the depth on the rack shown at the bottom. Careful consideration of these depths during the rack design layout is needed for the techs to gain easy access to the equipment when wiring the racks. The racks shown here are as they will be installed, bolted together. Also notice the use of helpful installation notes for the techs. And notice the power and ventilation requirements calculated earlier are placed right where they need to be on the rack drawings. And the same for overall rack dimensions on the bottom. This is the best place for sharing those requirements with the electrician, HVAC contractor, and carpenter. So that's about it for documents and drawings, but I want to talk about a few more items. We didn't talk about room layouts and theater designs. Why? Do we need to be doing this architectural work? In most cases, leave that up to the architects, cabinet designers, and theater designers. That's what they get paid to do. They can professionally lay out the rooms or cabinets with a simple sketch of the installed product's space, power, and ventilation requirements, which you can now provide. And for high-level theaters, that's a much bigger and separate discussion of design, configuration, and architecture with the client. Printed output. The symbol sizes and structure should be carefully designed so that the drawings are easy to understand even with very complex systems. All the drawings should be easily created in your office with inexpensive printers. This is just one example of a great $650 printer plotter that prints up to 24 by 36. The alternative to printing yourself and at your own convenience is to go to Staples, Office Depot, or Kinko's, or any of those companies. In either case, you should be printing fewer pages than you might have seen in the past because of more careful drawing layout design. As-built drawings. Putting things back where they belong when you're done is a great example of visual reminders in the world of drawings. Have you ever noticed how long it takes to find something that was never put back where it was supposed to go? The same is true with as-built drawings. As-builts are the result of marking up your job site master drawings, often in red, that reflect any and all changes that were made, usually out in the field. These marked up pages are then used to update the originals to as-built drawings. And no matter what direction you go or how you document your systems, make these changes. You will save time and money if you do. So, who will provide the documentation for your projects? If you don't have a competent design engineer to produce these documents in-house, you might be interested in outsourcing the work. But keep in mind, you will need to have someone on staff, usually a project manager, that knows your projects intimately, knows what to ask for regarding documentation, and can create basic sketches of the project layout. Here are some important tips for securing a good engineering partner company. This approach does require a good deal of communication between companies, and good communication is key, and without it, the rest doesn't matter. Find a service company that uses a private portal that allows you to share all the necessary documents securely and with little turnaround time. Do your homework here. Find the right company that has good communication skills and has this portal. Make sure they can provide the kind of design and engineering examples you saw in this presentation. The examples represent the important drawing features and details that are required to execute a project effectively. Make sure they're staffed by industry experts. Look at their credentials. Do your homework here too. By outsourcing your documentation, you get another set of unbiased eyes at your work, and this is a good thing. As an example, if you provide the team with a proposal and ask them to show it on a building plan, they may be able to identify gaps, overlaps, or other problems in your proposal before you present that to the prospective client. If you do have a competent employee capable and willing to produce these documents, you might be interested in doing the work in-house. Here are some important tips for establishing and maintaining in-house documentation. Many good design engineers have been installers, having a firm awareness of industry methods and requirements. They can better relate the drawings to practical real-world installations and vice versa. And of course, they're creating many of the documents for installers. But it's important that they stay dedicated to creating the project drawings and not be pulled away for other tasks too often. The employee needs to communicate well with sales, project management, installation, and service, as many of the drawings are created for these departments and may require extra clarification on certain aspects of the drawings. And good communication among the team is essential to keep the documents up to date. AV drawing software, there are many, and I can only speak to what SymbolLogic's ECAV ECAV can do. But at least now you've seen for yourself what is possible. And finally, concise, accurate, and easy-to-read visual drawings needed to build, program, and service our systems took years to figure out. What was necessary to show and what wasn't necessary to show in order to provide the most efficient visual documentation describing everything needed to install your systems. No more, no less. As stated in ESD, will the client understand what they purchased and where things are to be installed? It's not enough to just have a proposal. The potential client also needs something visual to back it up. And those visuals will also serve your install team in understanding what was sold and what the install looks like. Regarding NSD, it's not enough just to have the drawings to say you've checked that box. The drawings have to be organized and include everything you need in an easy to understand way. For the text to connect everything together correctly, for the programmer, for servicing, how much time would be saved knowing what's in the system and how it's all connected before having to roll a service truck? A truck may not even need to be rolled when preliminary service is performed in your office using the as-built documentation. And having the right documentation allows more available techs to build and service the systems and not just the lead techs. Also related to service is reliability. Is there enough power and ventilation for a safe and long-lasting system? You now know the answer to that and many other questions. And one last thing, in the past, it was really burdensome creating and managing all this documentation. But with more service providers, improvements in software, and training videos, I can honestly say it's now way more fun creating system documentation. Thanks for attending.